with the next talk given by Mathieu Munsch from the company Qnami. And this will be a trial, a technological trial. He will showcase live what they are doing at Qnami, and we all hope that the technology will allow that. So Mathieu, the floor is yours.
Can you hear me?
Yes, we can. And we can see you.
Great, wonderful. It's a great pleasure for us.
Wait, I think it's me.
That's you, yeah. It's not Mathieu.
Wait a second.
It's still you. Now it's Mathieu. Oh.
Wait a second. There we go.
Yeah.
Excellent. Thank you very much for this opportunity to participate into this third edition of QIDiS. It's a pleasure being here again. It's a pleasure to see that it's an ever-growing type of event. This year is a bit special, and since you're comfortably sitting in your place and I'm in Qnami, we thought we might, instead of showing a nice picture on a slide, just show you the instrument for real and how it works. Welcome to Qnami. We're right now in our application lab. So this is where we receive our customer, our future customer as well, when they want to try the system for the first time. This is also where we explore new application. And what's very special about that application lab is the system in here, which we have developed over the last 2 years, and which is the first scanning NV microscope. So here, Hai, our application scientist, has prepared a sample so that we can perform a small demonstration for you. Yes. And what's very special about that microscope is that it can measure magnetic fields on a nanoscale. Okay, you can engage and go. So the sample that we have in here is a very special sample that was provided to us by our collaborators in Paris. It's a research group between the CNRS and Thales. And the material is what is called a multiferrite. It's a magnetic material, and why is it so interesting is because it holds a great promise for the next generation of memories. In short, it has the potential to be operated at extremely fast speed, maybe 1,000 times higher than the gigahertz rate we have today. And it is also energy efficient in the sense that the cost of switching between bit 0 and 1 can be strongly reduced. So here I see that I has started the measurement. So what you have here is our LabQ interface. That's the software that we developed in-house, mostly under the impulse of Alex. And the image that is appearing right now corresponds to the magnetic field produced by the sample as we scan our tiny little quantum sensor over the surface. So it really shows up line by line. Now, why are we interested in such materials at all? Well, it is all about the future of computing. And it's important to realize that now computing is not just about improving performance. It is also about optimizing our energy footprint. It is critical now that we can achieve that result. And silicon has gone a long way, but it's not going to make it alone. That challenge is just too big right now. And in fact, magnetism will play a central role into that adventure. Just to show you a couple of graphs here, on the left, I have the number of scientific papers that were published over the last 20 years, which contains that keyword spintronics. Spintronics is the electronics using magnetic properties of the current. And you see that it starts from essentially 0 and grows up to a 1,500 number of papers published every year now. And this is not just science, it's also production. I'm sure some of you have heard about the magnetic memory called MRAM, which is now entering into production. It's a great technology and also a very huge market, which is growing at a crazy speed. But that growth projection over the next 5 years is actually dependent on entering a series of different markets. Right now, MRAM is used for edge computing, like the Internet of Things. At a later stage, it's hoped to be a replacement for flash memories. And then even after that, it could enter very close to the processor unit and be used in almost every computer. So that's the challenge. But you see that to get there, you also need to be able to scale down the technology, make the bit smarter, so that you can make the density higher. That's what is key. So this is exactly where our instrument plays a role. We are measuring these magnetic fields, and we are measuring them with extremely small resolution. Now I'm going to show you how we want to tackle the challenge of helping the scientific community as a whole. And I would like to drive you to our production room, where we are kind of preparing production capacity to be able to sell units by the tens. So let me show you that. All right. Here is Simon preparing the next order. Right now the room is empty, and I'm going to come back to that. We've just shipped last week the Proteus Q that we had prepared. But you see here that we have space and we have lineup preparations so that we can really produce units by the tens. And thanks to our strong collaboration and partnership with Oriba, a global scientific manufacturer, we have already now that global footprint so that we can reach out to customers in every corner of the world. Let me drive you to the office composites to show you the great news from last week. This is definitely our highlight of last week. We served that customer at the Fraunhofer Institute, so we're extremely happy about that. Very much looking forward to starting work with them so that they can use this technology for their own customers. And actually, you guys are here to do this for that week. Okay, before concluding, I would like to go back to the application lab and show you where we are with the measurement. I have to mention that this measurement is actually extremely challenging. Before this technology exists, you could simply not measure at all. It was not possible to see what you're going to see right now. And it was done the first time only 2 years ago, a work published in Nature. So I see that we're, 2/3 finished. It's a 1 by 1 micron frame that we're looking at right now. Pretty large for this ultra high nano type of analysis. And you already can distinguish very prominent features which are specific to that material. Okay, I think with this, I would like to conclude by saying that this application lab is really open, it's yours. If you're a scientist, if you're an engineer, and you have such challenges at your own place, and you want to challenge your materials with our system, the lab is here, the shop is open, and you can just reach out to us and we'll make a slot available for you. And with this, in the name of the entire team, I would like to thank you, all of you that attended the meeting today. And I'm very open to any questions you have. Thank you for your attention.
Thank you so much, Mathieu. It was amazing how you could present that. We like that. It's more interactive, and we see live what happens in your lab. Thank you so much. George, some questions?
No question at first, but I'm really impressed. I see you pitching at the Q-Starter from QCID a few years ago for a 1,000 Swiss franc award, winning that, not knowing what is a Q-Starter and for what do I do that. And now I see you walking through the company, and I see what your team is doing, and I would just want to say bravo.
Thank you very much. Anyway, if anyone has questions later, you have my email. You can contact me. You can contact us anytime. We're just open for you guys.
I would have a question for you, Mathieu. As said also before, we like and we love to see startups growing. How do you see you in the next 2 or 5 years? What are the new products that you are going to produce?
Yeah, thank you for the question. So the first thing, I'm going to jump on that opportunity to say that we are just at the beginning and we keep growing. So next year, there will be job opportunities. If there are students listening, watch out, there will be new job opportunities next year. We're extremely happy with what we have, and we now need to consolidate this first market we are entering. We're trying to understand our customer better, working with them. So definitely we have a strong activity in this scientific segment. And at the same time, we're exploring new applications, whether that same technology can be impactful in a more industrial environment. And also that is something a bit different, but for those who know the Quantum Foundry, Felipe, our CTO, is also providing a certain number of localized surveys for those who start working on quantum sensing with Qnami.
Okay, thank you so much. I think we have to leave you, and thanks again to our 3 pitches. And we are going now to start the second part of the session D.